All right, so learning goal. The student will understand how a dilation affects the shape of the image. Have you guys heard the word dilation before? Where have you heard the word dilation before? Dilated pupils, okay? Anybody else heard of a dilation anywhere else? Anyone have any, like, little siblings, like babies in their family? No. You do? Where else have we heard dilation? If you don't have any babies in your family, when a woman goes into labor, they say she's dilated. Yeah, and that's what that means. Her cervix is getting bigger because the baby's got to come out. So that's what that means. And they say once you're, I know this is uncomfortable, but once you dilate to a 10, baby can come out. And so they'll say that number. They'll say, yeah, dilated to a 3. You're not ready yet for the baby. So that is another place in life that you will hear that word. I know, it's real. All of you were born. You all have mothers somewhere.
Yes, even if you have a newborn baby in your family, it's not like you're going to be right there when the doctor yells that.
Well, they don't yell it, but most women going into labor, like they'll be at home, or even weeks up to having the baby. The doctors say you're dilated at a 3 or you're dilated at a 2. Like that's a very normal thing.
Okay.
Yeah. You want to talk about reproduction?
No.
Okay.
No. At least you have on my eggs.
All right. Okay. All right. And I guess I had a video, but I didn't watch it with last hour, so I guess I'm not going to watch it with you guys. Okay.
I know which one's dilated.
All right. Very good. So when you have a dilation, okay, the biggest thing is it has to stay the same shape. If it changes shapes, it is not a dilation. So let's look across those first 3. Which one of those would, how about let's start with the knots. Which one would not be a dilation and why? Chase?
Number 1 would not be a dilation because it stays the same size.
Very good. That's the exact same size. What is that movement actually called? What rigid? They're called rigid motions.
Slide.
Does anybody know the fancy word for slide? No? It's called a translation. And I always remember it's slation because that sounds like slide. So that would be a translation, okay? Which other one is not a dilation, Taylor? It changes shape. Very good. That is definitely not the same shape. So that leaves this one. This one is a dilation, and we're going to learn about scale factor here in a second. All right, look at the bottom 3. Which one is a dilation and why? Gavin? Very good. Yes. This one is not because they change shapes, and this one is not because that would be another example of a translation, okay? All right. So let's talk about this. Now, in geometry, it can be an enlargement like we talked about with the pupil, okay? Or it can be a reduction. It can be either one. So this is right here called an enlargement. How can you tell which one is the original figure and which one is the new figure, James? Okay, I'm going to show you what that line is here in just a minute. Lawrence?
The apostrophe is after the letters in blue shape.
Very good. And that's called a prime mark. And you'll see it, sometimes they call it tick mark or a prime mark. And so that is how you know that this is the new figure, is you're looking at that little prime mark right there. Okay, so this is an enlargement. We're going to talk about scale factor. 2 ways to figure out scale factor. I'm going to tell you how I usually do it because I think this is kind of the easier way. But basically when you find scale factor, you're going to put the new image over the original image. So the new image right here is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the original figure right here is 3. So if I put 9 over 3, 9 over 3 reduces to 3. Okay. The other thing you can look at, and the reason that those lines are here, is you're going to see this. This one is actually an enlargement, and they're going to say around the center, and this center happens to be 0, 0. And what that means is this is the starting point here. So the distance from here to B would be 1 unit. Here's 2 units. Here's 3 units. Okay, so I'll do that again on this other one. All right, so from the center to C is 1 unit, because that's the original. Here's 2 units. Here's 3 units. Oh. It's 3 units away, and I'm saying units whatever this is. So like this one would be, here's 1 unit, here's 2 units, so here's the 3rd unit.
What if it's not equal?
Well, it's whatever the scale factor is. So the scale factor could be 4. So then it would, if it was a 4, then I'd have to go out here.
What if it's not equal?
How'd you get 9?
Yeah.
Where'd I get 9?
Oh.
The length of the side right here is 9. Here's 8, 9.
Ah.
And then I came back here and said this is 3. And I can do that with any of the sides. This side right here is 2. This side right here is 1, 2, 3, 4, 5, 6.
Wait, what'd you say?
6 over 2 is 3. Which this is a rectangle, so there's only 2 different ones.
Yeah, if you stood the diagonal line up, it would be way
It
taller.
doesn't have to do with anything about the length of that. It has to do with how far it is away from its center. This is the center. This is what it's calling the center. So as this comes out this way, it's going to be 3 away, like that. 3 equal units away to enlarge it. All right, let's look at a reduction and we'll do all that again. Okay, so here's a reduction. So you can tell it's a reduction because here are the original letters. Here are the letters with the prime mark. Okay, it's getting smaller. All right, so the scale factor is now going to be a fraction. Anything that's reduced is going to be smaller than 1. Anything that's enlarged is going to be bigger than 1. What if the scale factor is 1?
Then you have the same thing.
You have the same thing, okay? So now if we look at this one, all right, so this is the exact same one we just looked at. So we know that this is 9 units, this is 3 units. So this time the new image, this is the new image, is 3. The original image is in black, it is 9. 3 ninths reduces to 1/3.
Oh, I
It's a
get it.
third of that original. Okay, so then last hour they were like, well then that means the area would be a third, you know, or the area would be triple that. So then we had a big lengthy conversation. So I'm going to show you, I actually drew this out so I can show it to you guys better, and I showed it to them. All right, so I've drawn a little picture.
How did you get 3?
All right, so here's a little picture for us to go through. Okay, so let's say that I went from this image to this image. Okay, so this is the side of 2 and 2. I'm going to use the scale factor of 2, so this becomes 4 and 4. We okay with that?
Yeah.
Okay, how many times does this box fit in this one?
2. What?
Yeah, how many times does it fit in?
4.
Okay, color good. It's in 4 times. 1, 2, 3, 4.
Whoa.
I know, right? Because they were like, well, if it's a scale factor of 2, it just means it's twice as big. 4 times as big. All right, so let's do another one. So if this side is 3 and this side is 3, and I want a scale factor, that's a 3. Then this side is 9 and this side is 9. How many times does this shape fit in here?
9.
9 times. Who knows what's happening? James? What happens to the scale factor? It does, yes. What if I just know the scale factor? Ashton?
The scale factor, sorry. You just have to divide this
No?
scale factor by 9.
Anybody else?
The scale factor times the length of your normal plane.
No?
Square root.
No?
The scale factor times itself.
What is that called?
That's
square root.
It's squared.
It's squared. Yeah, it's-
Square factor squared.
It's the square factor squared. Yeah, if you square the square factor, then you get area. And that's not something you have to know for digits, but last hour they kept saying, well, then the area is just doubled. And I'm like, no, the area is not doubled.
It's squared.
It's squared. Yeah.
So,
Times itself. Yep. 9 times as big. 4 times as big.
the reduction.
Okay, so let's look at this one. Is this one an enlargement or a reduction? Enlargement, good, because you can see where the prime is. Okay, so this means it's the new one. So this is 1, 2, 3. This is 1, 2, 3, 4, 5, 6. So what is the scale factor? 2. It's 2. The new image is 6. The original is 3. The scale factor is 2. Okay, you can do it from either side. This side is 1, 2, 3, 4. This side would be 8. 8 over 4 is still 2. Okay, there's our scale factor. All right. you guys go ahead and do this one, and then we'll do a harder one. You have to look at the prime marks. This has a prime mark, so that means it's the new image. This one's 1, 2, 3, 4. This one's 1, 2, 3, 4, 5, 6, 7, 8. So this would be the new image would be 4 over 8, which would be 1/2. And again, I said anything less than 1 is going to be a reduction. So if you thought it was 2, that means your figure would be getting bigger. This one's not getting bigger.
I got that.
Well, good.
Wow.
All right, try this one. All right, is this an enlargement or a reduction?
Reduction.
This is a reduction because this is the original. This is the one with the prime mark. Okay, which means that your scale factor has to be less than 1 to make it smaller. James,
Oh, it's 1/3.
what was the original that you got?
The original
2 over
6.
6. So 2 6 reduces to 1/3. Okay. All right. Harder one.
What?
All right. Try that one.
The one that's not slanted, so the one that goes straight across, so you don't have to count the slant.
So you either have this option, or this option, right? Okay. Which option did you go with?
I went with one on the bottom.
One on the bottom. Okay. So we're going from this outside one, so here, and then we're comparing it to the first prime, which is here. Okay. So what did you get?
9 over 13.
9 over 13. Okay, and then you always reduce it. This one can't reduce. Now, last hour we looked at this side here versus this side here because they said, well, this will always work. Do you notice that this is not sitting on a perfect cross section? Those are called lattices. Okay, so I went in and figured out exactly what it should be. This should be 12.6. It should be. That's what it is. This is
Riley Estes, please come to the office to be
This is
dismissed.
7.
Riley
Okay,
Estes.
now watch how I'm going to make it the same as this. Okay, this would be 7 over 12.6. You cannot have a decimal inside of a fraction, right? So what do you have to do?
Put it over 1, so it's 76.
Yep, and then you have to simplify. And hey, guess what goes into both of these? 14 goes into both of these. And guess what happens when you reduce it? You still get 9/13.
Wait a second.
Okay, it's the same thing. So, all right, let's move on to the next part then. All right, so the next part is finding coordinates. Okay, so this says find the coordinates of the image of ABC after a dilation with a center of 0. So it's starting here, and then all you're gonna have to do if the scale factor is 2/3, you just have to multiply each of these by 2/3. Okay, so if I want to know where the new A is going to be located. The new A, or the A right now is at 3. I take that times 2/3. I have to be able to multiply fractions, and I get 2, which is what they got. If I want to know where the new A is, the new Y is, then I take 6 times 2/3.
4.
And again, I have to know my math, and I get 4. So the new A prime would be located at over 2, up 4, 1, 2, 3, 4. And that would be the new A prime. Okay, and I could do that with each one of them until I got my new triangle. So, all right, so all we had to find was the coordinates of n prime, right? So we take the original one, which is n, which is 8, 4, and we're going to multiply the 8 by 3/4. So 8 times 3/4. So that is 6, good. So n prime is 6. And then we're going to multiply 4 by 3/4. So 4 times 3/4 is 3. So n prime is 6, 3. That would be where the new n prime is. Questions on that? All right, let's try to put this all together then and see how far we can get with it. All right, so this one, yeah, you're just multiplying by 3, multiply by 3. So -6, 3. -6, 3. Okay, and then my last one, what am I going to get for C prime? -3, -3. Remember how I said these negatives are not going away? They're just going to keep coming up all the time. All right, so let's go ahead and graph those then. Okay, so again, if I want to look at the rays coming off of center, it says the center is 0, 0 right here. So watch how this goes through one box, through 2 boxes. What happens here? There's 3 boxes. There it is. If I'm going with A's, it kind of goes over 1 and up 2, over 1 and up 2, over 1 and up 2. So it's the distance of 3.